Hi, I'm Jonathan Rodriguez.
I'm Gustavo Naranjo.
And I'm Tam Ngyuen.
And this is our Laser Harp that we made for Professor Gerfens CPE-329 final project. Here's a little demo. So, as you guys can tell, I'm no professional musician, but this was playing sound, and there are no strings attached. Ta-dunch. So what we have going on here is this is a MIDI controller, and this sends digital data to our MIDI synthesizer over here. So the MIDI controller tells us when to play a note and when to stop the note, and the MIDI synthesizer actually gives us the sound. So Gus will tell you a little bit more about the layout of our harp.
Okay. The overall layout of our harp is we have lasers on the top, and on the bottom we have photoresist sensors, which basically detect all the different lasers being as they hit. Each different sensor produces a different note, as Jonathan had mentioned, and also the light from the sensors that's being detected is basically converted into a MIDI signal through the ADC-10, and Tam will talk more about the software aspect of our whole entire harp.
So the way this device works is we have 7 individual lasers hitting 7 individual photoresistors, and we've programmed each one to play a separate note inside a chord, so A, B, C, D, all the way to G and then C. And so the way it works is when you trigger a light, this sends a signal to the ADC-10 in our MSP430, which calculates a threshold, decide whether or not this gets triggered. And then from there, a standard MIDI signal gets sent to our MIDI controller, which is also inside this device. And inside that MIDI data signal, it has 3 bytes. The first byte says whether or not to turn the sound on or off. The second tells you what kind of note it is. So right now this is a C note, right here is a B note. And then the third byte would be how fast the note gets played. And right now we have it playing at a standard speed. Aside from that, if you come over here, we have a switch that we implemented that can switch the channels of our individual lasers. So at first we had each photoresistor connected to channel 1, but after I switched that, each photoresistor now has its own channel. So as you can see, they all play their own separate sound.
And each channel can have its own instrument attached. So you see that can make one sound, maybe a harp, maybe an organ, maybe a piano over here, or a trumpet over here. Point being, you can have multiple, or you can play multiple instruments assigned to individual strings. So you can have up to 7 instruments on this one harp playing at the same time, as opposed to playing just one instrument with an array of frequencies that you can access. And going into the photo sensors a little bit more, what we have going on, like Gus was saying, is the laser emitter up here, photo sensor down here. And the way we're triggering the signal is with a simple voltage divider. So we just run VCC to a resistor and then create the voltage divider here with our photo sensor. The photo sensor is actually a variable potentiometer, meaning it's got a variable resistance. And that gives us different signals here at the center node. So this is the signal that we're reading with our ADC-10. And we turn that into the digital domain, obviously, with that ADC, which we can then compare against a threshold value to decide if we want to send a note on or off. So going into the strength and power of this technique that we used with the MIDI signals, we can see a little bit of the power that we have at our hands now that we can talk MIDI. So this is Ableton Live 9. This is what we're interfacing our MIDI device to. And this is the bank of instruments that we can actually assign to our harp. So this is a little bit of a limited collection here because this isn't obviously the full version, but there are tons of different instruments that we can assign. And are we still in beat mode, or can you switch it back? So with a quick switch I can change the instruments. So there's one instrument, and I can just come back over here really quick and slap on another one and come back, and it's that easy to change the instrument that we're playing. It's fully customizable. As Tam was saying, we could assign multiple different instruments to the harp at the same time, like one instrument per string or whatever, so we can access all those instruments from here and just assign them to our strings. So again, we can even layer these. So here's another sound. We can turn that off and use a different sound, or we can play them both at the same time. I don't know if you could really hear that those are blended, but let's try something else. I know there's this one that will work better. Better demo. So a little drawn out part in the back, that's a different sound. I can isolate it so you can hear it. One sound, separate sound, and then both of them at the same time. As you can see, by choosing to go through the MIDI route and using this Ableton interface, we are given a lot of freedom and options with the sound that we want to assign to our harp. So this harp here actually is a pretty powerful musical instrument, and you have a lot of control on what this thing can do. So it's a fun project. Thanks, Gerfens.
Thank you. Thank you. See you soon.